Hello everyone, in this video we will be going through the PlanOpSim simulation software and learning how to define parametrized structures within the simulation. Let's start from a blank simulation. So the first thing we'll do is add 3 layers, a substrate, a top layer and then the actual micropillar layer. So we'll start with the substrate, call it substrate. The structure of this will be homogeneous, so we select homogeneous from the menu. The thickness will be 0 because it's the bottom layer. We'll save that. Then we go on to add the next layer, the pillar layer. Call this one pillar. Also choose the structure. Now in this case we want to choose a parametrized structure, which will be any of these 4, either circle, rectangle, trapezium or cross. So in this case we'll pick circle, and we also need to set the thickness. Let's start with 100 nanometer. Save that. And now you'll notice that here on the right hand side in the top view the image of the circle has appeared, as well as below here we have the materials inside the pillar and the structure parameters in the lowest field. We'll get to editing those in a minute, but first we'll add the third layer, which will be the air on top. We'll call that air. This is again a homogeneous layer, and its thickness will be 0. Save. There we go. And now the top view has changed back to a single color image because we have again a uniform view in this homogeneous layer. So let's go to the pillar layer once more and edit the materials. By default we have potassium here and gallium arsenide. That's not actually what we want. Here in the center of the layer we would like to have, for instance, silicon nitride. There is silicon nitride. We save that. And then for the outer part, outside of the pillar, we will use air. So we'll go to this material, click it, and also say air. Voila. And now we have a pillar made of air and silicon nitride. Below the materials are the structure parameters. You'll see there are 3 for a circle. There's the radius, the center coordinate, that's the central position of the center of the circle, and the resolution with which the circle is created is discretized inside the layer. So let's change the radius now for once from 250 nanometer to 150. And we'll save that. And we see that the top view has changed to a different structure. That's the definition of our circle is now complete. So now we still have to continue with the definition of the rest of the simulation. We still have the substrate here, which was at first having an air as material. We will change that to silicon dioxide, just for the simulation. Save. And the air layer, which was having, also needs to be set to air as material. And there is one more thing, that the substrate is now the top layer. We actually want it to be the bottom layer, so we will move around the substrate layer. We select it, move it up. We also move down the air layer to be the lowest layer. And save that. And with that, the definition of the structure itself is complete. What we still have to do before we can run the simulation is set the incident light. We will go there to the incident light tab here just below structure. Click there. We need to set the angles, polarization and wavelength of the incident light. For now we are happy with this. I will just set the wavelength to 532 nanometer green wavelength. And then we can go on to simulation settings just below incident light. Here we have 2 important things to set. Number 1 is the sweep variables, and number 2 is the accuracy. Out of experience, we know that accuracy needs to be around 3. That 3 is a good setting at first for both the x and y direction. And then we get to the interesting part, the sweep variables. This is where you will actually define the systematic variation of parameters in the simulation. So let's add 2 sweep variables. Number 1 will be the height and number 2 will be the radius. So we click add, then we enter an alias for this sweep parameter that will be height, and a type which will be a linear change, and then we need to set the start, stop and end values. For instance, we change the height from 100 to 1000 nanometer in steps of 50. We can save that again, and then we add one more parameter, the radius. The alias will be radius, the type will also be linear, and we will change the radius from 10 nanometer to 250 in steps of 10. You can save that. There we go. We now have 2 sweep variables that we can assign to any parameter inside the simulation. So we want to assign these to, on the one hand, the layer thickness, and on the other hand, the radius. So let's get back to the structure tab here. Go into our micropillar layer and go to the thickness column, and the 100 nanometer that we had there before, we will now change that not to a number but to equals height. We save that, and now the simulation will systematically vary the height according to the parameters that we entered in the simulation settings. We also want to define our second parameter, the radius, here by editing the radius entry, not 150 nanometer but equals radius. Save that, and now we also have the radius set for a systematic variation. That's all we have to do in terms of simulation setup. So now we can go ahead and launch the simulation by going to the 4th tab, the simulate tab here below, and we will click launch simulation, and then the simulation will start. We need to give the server some time to finish running, and then we'll get to examining the results in a minute. Okay, welcome back. Our simulation has now completed, so we're ready to start analyzing our data. We see that over here we have a little message saying that the simulation was completed, and we can now add plots to inspect it. So let's just, for the sake of it, add one plot of a heat map of the transmitted power as a function of the radius and the height. So we go here, we add a plot, we go to plot type, which we will set to map. For the output settings, these are all, the defaults are actually okay. We want to see transmission at the power coefficient in absolute value. But the only thing we still have to define is over here, these sweep variables. We see that we have 2 sweep variables, the ones that we set earlier, the height and radius, and we can choose on which axis we want these 2 variables to be plotted. So let's say we want the height to be the y-axis, so we'll select y, and we want the radius on the x-axis, so we'll select that as well, and then click update and let the plot be generated. So this couple of 100 simulations that we had run just now will now be post-processed in order to get the transmission from the simulation. And there we have it. So here now we have a heat map showing on the x-axis the radius, on the y-axis the height, and the colors represent the transmitted intensity for TE polarization. We can then go on and add and analyze this data further, but that's all explained in a different video. So thank you very much, and see you next time. Bye.